Hello. So thank you for watching this lecture video. So we just had our second exam. So second exam is about one sample problem. We say one sample problem. We say exam two. Exam two is about one sample problem. Okay. Okay. So this exam two, I found most of you did a good job. So thank you for your good performance. Okay, so we say exam 2, exam 1 is probability, the population. Exam 2 is about statistics. So first problems, we can say the one sample problem. So once we have data, we can do this, we can do that. So then, from now, we will move to other problem. So we have one sample problems, then we have two sample problems, and many sample problems, like those things, right? So today's topic is two sample problems. So the first, let's review for one sample problem. Okay, so one sample problem is, so we have like one sample data, like x1, x2, so xn, we have those data. So from those data, what we can do? So usually we can do two things. First one, estimation. We say first one's estimation. So meaning from this data, we want to estimate usually population's mu, population's average. So we have those kind of problem now. Find confidence interval for mu, for population's average. So we have those formula, right? X bar plus minus Z star, or X bar plus minus T star, like those, right? Okay. So here we say, T star, Z star depends on whether we know sigma or we don't know sigma. Or we have to use A's. Then we have T star or T distribution or T table, right? Okay. So the other thing is hypothesis testing. So some people say mu equals this number, but we don't believe. Some people say mu equals this number, so we believe maybe mu is larger than this number or less than this number, or not equal this number. Okay, so we can say this is one tail test. We just consider one side, right? So for this one, we say the two tail test, right? So how to conduct those tests? We say at the first find, calculate a test statistic. So sometimes we say z value, t value. Okay, so then how can we determine? So then we just need to determine this test statistic is big. This test statistic, this number is big or small. If this big, then we say our sample mean and a sample mean x bar and mu 0 and the equilibrium is differ very much. So we believe equilibrium h mu equals that number, mu equals mu 0 is not so true, right? So how can we determine this test statistic is big or small? We can have two ways. First one is p-value. We just compare p-value with this alpha. Okay, so we call this alpha is significance level. And we also can compare the test statistic with a critical value. So those critical values sometimes we check from Z table, so we call this is Z critical value. Sometimes we just check from T table, so called T critical value, right? So compare, use that critical value to as a standard. Then determine this number is a big number or small number. So make a decision is if there's a test statistic is big, then we say difference is significant. If it's not so big, so we can say difference is small. So we can accept it, we can believe mu equals that number, right? So this is one sample problem. Okay, so for two sample problem, so meaning we have two samples, we have two sample data. So from this sample, we have those data x1, x2, and xn1. Suppose there's sample size n1, and there's another data y1, y2, yn2. So there's sample size n2. So once we have two, we have two set of data. A typical question is we just compare, right? So we can say our second topic in statistics is comparison. Compare. If we have two or many, we need to compare, right? Which one is better, or which one is the best if we have many, right? Okay. So typical question, if we have two treatment, we will check whether treatment A is better than treatment B. If we have two classes, we can compare. We want to check whether class 2 is performing better than class 1, right? So comparison is a very common story in our daily life. Like if we have two people or two things, we always need to compare which one is better, right? So how can we compare in statistics? Okay, so this is again the foundation of statistics is essentially limit theorem, or x bar follow this normal, follow a normal distribution, or this we call sampling distribution, right? So x bar from the sample, we find sample mean will follow normal. So here we say no matter whether the distribution or the population follow which distributions here. So from this population, take a sample. So then this sample mean we know follow normal. Okay. So two sample problem is just like from this population we take a sample, okay, and from another population take a sample. So for these two populations, they are not the same. So this population mean is mu1 and standard deviation sigma 1. For this population, mean is mu2 and standard deviation is sigma 2. So from here, take samples. So we say we have x bar will follow normal, right? So this sample mean will follow this normal, and this sample mean, so we put y. Okay, y bar will follow normal, right? Follow this normal, and x bar follow this normal. Or more specific, we say x bar follow this normal. Mean is mu1 sigma 1 over n1. Y bar follows us. Okay, so x bar, y bar, both of them follow normal. So this is central limit theorem, or this is sampling distribution, no matter for the population, right? Okay, so here we say the normal minus normal is still normal. So we have this result normal minus normal, x bar minus y bar, follow this normal. So mean is mu1 minus mu2. But the standard deviation is this. So we can say that now standard deviation we cannot use minus, right? So standard deviation for this, let's say for this population, standard deviation is sigma 1. For this population, standard deviation sigma 2. So if so put it together, so we say like so x bar minus y bar. This standard deviation we cannot use this sigma 1 minus sigma 2. We cannot use this. Why? So let's say suppose sigma 1 equals sigma 2. So this means their values, the change mean quite the same. So if we use this sigma 1 minus sigma 2, this becomes 0. So this means no change. This makes no sense, right? Put it together, they still have some changement. Okay. Okay. So here we say that we have this result. We say if we put them together, then the values should be added them up. So for this one, values is sigma 1 square over n1. And for this one, values is sigma 2 square over n2. Then put it together, values plus. If x bar minus y bar is plus, and even for x bar plus y bar is also the same, right? We can say like if we put the two samples together, the values should be added up. Okay, so then the square standard deviation takes square root, right? So we have this. Okay, so now this is general normal, then change to standard normal, we have this, right? X bar, this minus mu, x bar minus y bar minus this mu, divided by this sigma, follow standard normal. Okay. So we have this, these things follow standard normal. So we say for two sample problems, we usually is the comparison, compare. So compare what? Compare mu1, mu2. So here HO always mu1 equal mu2. Meaning there's two samples, two data set. Basically no difference. Then HA is have difference, right? No difference, have difference, and more specifically, have difference could be larger than or less than, or simply not equal. Not equals have difference, right? So here, HA, again we have three options. So which one we should choose? It depends what the good meanings, right? One side is means good, or two sides means one side or good means close means good, or one side is good. So this depends on our question, or depends on situation. Okay. So now let's say we find test statistic. So we say under HO, we say mu1 minus mu2 becomes 0, so we can remove it. We can forget this mu1 minus mu2, so we have this result: x bar minus y bar over this follow normal, follow standard normal, right? Okay. So So the story quite the same. So if we assume we know sigma 1, sigma 2, then we can calculate this number. So we say this is z value, right? We from sample 1 we find x1, y from sample 2 we find y1 x1 bar, x bar, y bar, find sample average, and we have sample size n1 n2, right? And if we know sigma 1, sigma 2, then we can find this number. So this is tested statistic. So this follows standard number, so this is we call this z value. But we say in real situation we don't know sigma 1, sigma 2, right? Okay, so if we don't know sigma, then we just replace sigma by s, right? So we have this number like so replace sigma 1, sigma 2 by s1, s2. So we have this test statistic. This test statistic, okay? X bar minus y bar over this. So we can easily calculate this number, right? We can easily calculate this test statistic. But the question is, how can we determine this is a big number or small number, right? Then to determine this big number or small number, we need to find a p-value or find a critical value. So p-value and critical value depends on its distribution. Find the problem. So how can we find the p-value, or how can we find the critical value? So which table we should check? Z table or T table or other table? Okay. So this here we have this question. These things follows which distribution? If we follow the standard normal, then we check Z table, right? If we follow T distribution, we check a T table. Okay, so we should know, and also like if maybe these things not follow Z table, not follow Z, not follow T, to follow others, then we want to find these things follow which distribution. So such a question actually is tough. These things follow which distribution. Okay, so we say its distribution is quite complicated. So we can solve. If there's too complicated, then we just use approximation. We say roughly this thing follow T close to T distribution. Okay, so we say close to this approximate or close to T distribution. So for T distribution, we should determine degree of freedom. So for one sample problem degree of freedom, we remember degree of freedom equal n minus 1. So here we have two samples. So we have two n's. Then what is the distribution for that? What is the degree of freedom? So here again, the exact formula for degree of freedom is quite complicated. So here again, so we say roughly, we just use this. We like take smaller minimum, a smaller one of n1 minus 1 and n2 minus 1. So n1 minus 1 is the degree of freedom from sample 1. N2 minus 1 is the degree of freedom from sample 2. So we just pick a smaller one. So here again, we have this question. Why we pick a smaller one? Why we do not pick a largest one? we say why this not work? Why we pick minimum? Okay, so here we say if sample size big, this means good, right? So here we just consider worst case. We just check almost like a worst case. Or to make our decision, we just try to be really conservative. Okay, so we just pick a smaller one. Okay. Okay. So then we can say that these things follow close loosely follow tedious distribution with a degree of freedom is n1 minus smaller one over n1 minus 1 and n2 minus 1. Okay, so once we know this follow tedious distributions, then we can find a critical value from T table. Then we can determine this is big number or small number. Then we can make a decision, right? Okay, so now let's consider this problem. Like so here we have two classes of Math2526, and we use the same exam. And so suppose I teach class 1 and my class average 84, and some other guy teach class 2 and their average 81. So from the result, it seems like my class, our class, do better than other class, right? Based on this average. So the question is whether this evidence is strong enough, or can we say class 1 performs significantly better, significantly better than that of class 2. The performance of class 1 is better than performance of class 2 at this level. So here we say instead significance or significant is keywords. We have evidence. We want to check the evidence is whether the evidence is strong enough or whether the evidence is significant. Okay, so for such a problem, we just convert this as a testing problem, right? So at first, it's the hypothesis. So it shows mu1 equal mu2. So here mu1 means like average of class 1. Mu2 is average of class 2. So here, don't get confused. Like here, we say, oh, class 1's average 84, right? So 84 is only for one exam. So mu1 means for if we have many exams, that mu1 average for class 1. So this is just only one sample. We only take one exam. So 84, right? Okay. So if mu1 equal mu2, then we say no difference. Even though this time for this exam, class 1 perform better than class 2. But maybe next time they will close, or next time class 2 can be perform better than class 1, right? Because essentially they are quite the same. There's two classes quite the same. Okay. So HA, we said this is one side because we talking about the average exam score, right? So the higher the better. So we just check out one side, right? Then find the test statistic. So just the x bar minus y bar over s1 square over n1 plus s2 square over n2. So we just plug in here. So 84 minus 81. So S1, the sample standard deviation for class 1. So S1 is 7, S2 is 9. So here just 7 square over 25 plus S2 square 9 square over 20, right? So so here we can oh, so we need a little bit of calculation actually, right? So we use Excel, or let's say okay, so let's say, okay, not use okay, use calculator, let's say okay, so let's say 49 over 25 plus okay. Oh, there's a calculation to this. So let's see. Do I have? Can I use Excel? Oh, let me turn it down to this. Okay. So use calculate. Take time. Yeah. Let's say use calculate over 10. My calculator is not so good, so take it. Oh, okay. Okay, then plus 1.9. Okay. Okay. Okay, so I find, oh, finally I got this number, the 1.22. Okay. Okay, so then this number is a big number or small number? So we need to find critical value, right? So we need to find, so this is t, so we need to find t critical value. So how can we find this number, or how can we find this value? So we need to check a t table, and for t table we need a degree of freedom. So here degree of freedom, so we have two numbers, 25, 20, so we just pick a smaller one, the 20 minus 1, so equal 19. So let's check a t table, degree of freedom is 19, and one tail or two tail, so that's the one tail, right? Yeah, one tail. So let's check a t critical value. So yeah, okay, so here's the t table. Yeah, so degree of freedom is 19. This one, degree of freedom 19, and so one tail 005. Okay, this one, right? I'm sorry. One tail 0, this one. Okay, so we find this is 1.729. So this is t critical value. So compare, so use this, let's say, use this 1.729. We just use this as standard. Use this to judge it. We say, oh, okay, so we find this 1.22 is small, right? So we say this number is small number. Okay, so small number means this difference like 84, 81, this difference is not so big. Okay, so our decision is these two classes, even though we can say 84, 81, their difference is not so big. So we can believe these two classes, their performance are quite the same. Okay, so can we say class 1 is better? No, right? No, we cannot say class 1 is perform significantly bad. Looks bad, but not so significantly. Okay. Okay, so this is exam 1, so easy, right? So just the process quite the same. Find the t-value, then judge this. Find the test statistic, t-value, z-value, then judge this big number, small number. Okay. Okay, so now let's consider the problem like who is more popular or who will win the election. So suppose like we want to compare two candidates, we do a survey and okay. So so for this guy, candidate A, his let's say his percentage is 42, right? We can say among 1,000 people, 420 people like him. Then this is 42. And for B, so for B, P2 hat, his percentage is 900 over 2,000. So just equal 45, right? 45%. So this guy is 42%, this guy is 45%. So can we say, so we have evidence, right? It seems candidate B is more popular than candidate A. So here we just, okay, so we have this evidence. Then we need to check this evidence, the significance of this evidence. Or this evidence is strong enough. Okay. Okay. So we convert this as a testing problem. So HO, their proportion quite the same, and HA, we can say P2 is larger than P1. So this HA is candidate A is significant more popular than candidate A. Okay. So for test statistic, so we use this we use this formula: x bar minus y bar over s1 square over n1 plus s2 square over n2. So in this typical situation, so x bar means, so for this 1, 0 data, the x bar is p hat 42, right? And y bar 45. And then s1 square, so s1, or we can use this like just like sigma square. We have this for 1, 0 distribution sigma square variance equal pq. So s1 square, so we also can say just equal p1 hat q1 hat. Okay. So P1 is 42, so then 42 multiplied 58 divided by N1. N1 1,000. So plus S2 is 45 multiplied 55 divided 2,000. Right? So after a little bit of calculation, I find this equal negative 5 1.57. Okay, so then we need to determine this is big number, small number, or this number is far away from 0 or close to 0. So 0, I'm sorry, here 0, negative 1.57. So these two numbers close, not so close. So here we have two ways we can find the p-value because this is z, so why this is z? Why not this not t? Because the sample size is quite big, right? So we just use z. Okay, so we can find p-value. So p-value just so this is z table, right? Z distribution. So this is p-value. Okay, so we just check 1.57, then 1 minus, right? Okay, so let's check 1.57, 1.57, 1.57 thus, okay? But we need to use 1 minus, right? So this is p-value, this equal, let's say 8, right? So this is p-value 0.00582. Okay, so let's go back. We say p-value, so p-value equals 0.00582. Okay, so this p-value is big or small. We just compare with alpha. So what is the alpha? So it says alpha is 0.0. No. Okay, so here no alpha. If there's no alpha, then we will pick alpha as 0.005. So we say by default, we will pick this alpha. Okay, so we find compare 0.005. This is larger than 0.005. Okay, so larger than 0.005. So this means this p-value not so small, not so small. Okay, so this means this 1.57 is not so big, small, close to 0. So we can say this is a small number, or we can say this two people's percentage, like 7% or 3% difference, is not so big. So we still cannot say candidate B is more popular than candidate A. Okay, so this we use p-value, compare p-value with alpha to make our decision. So the other way is we can use like critical value. Let's say critical value. Then we compare critical value with this test statistic. Then we can judge this big number, small number. So how can we find critical value? So this is z. So we will check a z table, and then this critical value we call z critical value. So let's check this z critical value. So this z critical value is check z table. Okay, z table. Okay, and alpha is 0.005. So we need to find this cutoff point such that this is 0.005. 1 till 0.005. So this number is z critical value. Okay, so let's check this number. Okay, so we can only check a positive, right? So we check only positive part. So we check this. So this is 0.005. So what is this cutoff point? Okay, so if this is 0.005, then left side all the way down is 95. So we just check where is 9500. Okay, 9500. So we find this number should be 1.64 or 1.65 or 1.645, right? Okay, so we can say this is our critical value. Okay, and critical value is here. So this is negative 1.645. So we use this number to judge. So let's see, big number, small number. So here 0. So here negative 1.645. So we say, so those number here, we can say big number, or this number is quite far away from 0, and so those number is close to 0. Okay, so negative 1.57 is here, so we can say, oh, this number and 0 is close, right? Okay, so we can get the same conclusion. A p-value and a critical value, the two methods are same. Okay. Okay, so now let's check this problem. So the problem part is the same. Like we wanted to compare two companies something. So companies what? We did compare whether the customer certification with their surveys. Okay. Yeah, we will check the customer certification level. Okay, so how can we judge this? So we just do a survey, ask people to say like whether you will like their surveys. So we use 5-point scale, so 1, 2, 3, 4, 5. So 5 is most satisfied. So 1 means not so satisfied. So 3 means between, right? Just like that. Okay. So we are quite familiar with those things. Like for the teacher's teaching, what you learn, what is the rank you can give to him, or what is the point you can give to him. So not always yes or no. We can use this, or one, you give the professor a score. So you can give him 5 points, or 3 points, or 1 point, right? Okay, so we get this result. So for company A, we checked 174 people, and their scores average is 3.51. So with the standard deviation is this. So data just from just 1, 2, 3, 4, 5, those numbers, right? And B, company B is average is 3.24. So here we say, oh, we have evidence, right? Because 3.51 is larger than 3.24. So then we need to check whether this evidence is strong enough that we can say, oh, company A's customer certification is higher than that of company B. So can we make such a conclusion? Okay, so then we set this as a testing problem. Compare two samples, right? So first of all, hypothesis mu1 equal mu2, the average, no difference. Then H is, oh, mu1 is larger than mu2. Okay. Okay. So then check test the statistic. So this is just uses x bar minus y bar over s1 square n1 is 2 square over n2. So we use so x bar is 3.51, y bar is 3.24. So s1 square, we find s1 is 0.51. So we just plug in here. So we find this number equals us 5.64 or 5.684. Okay, so then we just determine this is big or small. So we need to check so we need to check T table or Z table. So we say here, because the sample size is quite big, Z table, T table doesn't matter. And the other one is this number 5 point something is big. Like for, let's say, like for standard normal, for normal we believe above 3 is big, right? For T quite the same, above 3 is big. So without check a table, we can say this big number. Okay, so we can make a decision. Oh, the difference is big, it's huge actually. We can the difference big. So 3.51 is significantly higher than 3.24. So we can say a company A, the customer certification level is much better. Their service is much better. Okay. Okay. So this is today's topic is two sample problem. So we say two sample problem. The process for testing is quite the same as one sample problem, right? Just find test the statistic, then check the table. Okay, so only thing the formula is different, right? So here we use this formula. This test the statistics x bar minus y bar over s1 square over n1 plus s2 square over n2. We use this formula. Then once we have this data, so determine this big or small, we need to find a critical value. So we can check sometimes check a Z table, sometimes check a T table, right? Okay, so I think those things are quite the same as before. So those things are easy for everyone. I hope it will easy for you. Okay, okay. So this is the topic for our class today. Okay, so thank you for watching. Okay, so thank you.